Well, hello. I am here to talk to you today about the equilateral triangle theorem. Okay, and here's what it says. It says if a triangle has three congruent sides, it must have three congruent angles. Similarly, if a triangle has three congruent angles, it must have three congruent sides. So let's try to understand what this means. If we have a triangle that has three congruent sides, we can automatically assume that the three angles are also congruent. And vice versa. If we have three congruent angles, we can automatically assume that we have three congruent sides. That's what the equilateral triangle theorem is, and we want to keep that in mind as we go through the next examples. So find the measure of all the angles in the triangle. Well, if we look at this lovely triangle, we notice that all of the side lengths are 8 centimeters. So we have three congruent sides. Well, our equilateral triangle theorem tells us that if a triangle has three congruent sides, it must have three congruent angles. So we have three congruent sides, so that means we must have three congruent angles. Now we actually got to find the measure of these angles. Okay, well, we know that a triangle adds up to 180 degrees. And we know that all three of these angles have to be exactly the same. So we can just go 180 divided by 3. Makes 60 degrees. Fun fact, that will always happen in an equilateral triangle. All three angles will be 60 degrees. Moving on to example number 2. Find the measures of the two missing side lengths. Right now, we know that this side is 7 feet. We do not know what the other side lengths are. But we do know that we have three angles in this triangle, and all three angles are 60 degrees. Well, our equilateral triangle theorem says if a triangle has three congruent angles, it must have three congruent sides. So I can automatically assume that all three of these sides have to be the exact same thing. So if one of these sides is 7 feet long, all of them have to be 7 feet long. Pretty cool, right? Moving on. Find the value of x. Let's dissect this picture a little bit. Right now we have two side lengths, 5x minus 12 and 3x minus 4. We're trying to find that value of x. But we got to pull some other information from this picture to help us do that. Well, in the picture we have these congruency marks telling us that all three angles are the exact same. Our equilateral triangle theorem says if a triangle has three congruent angles, it must have three congruent sides. So those three congruent angles tell me that all three sides are automatically the same. So if all three sides are the same, this side has to be the same as this side, which means this expression has to equal this expression. So we can make an equation for this. 5x minus 12 equals 3x minus 4. Let's solve this equation. I'm going to start by subtracting 3x from each side, so I end up with 2x minus 12 equals negative 4. Now I'm going to add 12 to each side, which gets me at positive 8. Divide by 2, and x equals 4. But now I'm being asked to find the side lengths over here. Okay, so we're going to take our value of x and we're going to substitute it in. Okay, so we're starting with side EF here. So I'm going to take this value of x and I'm going to plug it into side EF. So 3 times 4 minus 4. That makes 8. Now let's find the value of DF. Plug this in. 5 times 4 minus 12. Also makes 8. Oh yeah, well that's a good thing because remember we said that this was going to be an equilateral triangle. So these two sides got to be the same. And DE also has to be 8 because it's an equilateral triangle. Pretty darn neat, huh?